This is episode 12 of Vanessa. Vanessa!
Vanessa ventriloquist!
Oh, I'm sorry. I didn't know class had started. I should introduce myself. Hi, I'm Vanessa ventriloquist, and I'm here to tell you how to do the lever experiment. The question we ask ourselves in the lever experiment is, do machines make work easier? My hypothesis is yes, machines do make work easier. All right, let's find out what our materials are. Okay, the first material I always use is something called a spring scale. This spring scale is a major factor in finding the work of our object. Another factor in finding the work of our object is something called a ruler. After that, you'll need to make your lever. To make your lever, you'll need something called a fulcrum. For me, I'm using this mug because of its cylinder type shape. After that, you'll need to make your seesaw part of your lever. For me, I'm using a nice long wooden plank. After that, you'll need something that you can weigh and put on the lever. Maybe a small weight or a rare dinosaur egg. But for me, I'm using this very rare giant sushi roll. After that, you'll need some tape because you'll definitely be doing a lot of taping onto your lever. All right, don't forget your safety goggles. Almost forgot. All right, let's get started. Okay, the first part in our procedure is just lifting our weight, or in this case, giant sushi roll, and gently hooking it on to our spring scale. Next, get your ruler out. Now, we're going to lift our giant sushi roll exactly 6 centimeters. Wow, would you look at that? It's exactly 2.5 newtons. Well, on to the next part of our experiment. Okay, so for the next part of our experiment, I'll need a volunteer. Anyone, volunteer!
I would love to. Vanessa?
Oh, that's great. Okay, what's your name?
Peanut.
What's your last name?
Butter.
Oh, that's a brilliant name. Okay, so what I'm going to need you to do is place these 1, 2, 3, 4 fingers into the mug and place the thumb right on top of our fulcrum seesaw part. Okay. Wow, you're great at it. Okay, now with your other hand, we're going to use our ruler. Now just hold on to this ruler. Thank you. Okay, now I'm going to gently step over here. Now, I'm going to pull our giant sushi roll 6 centimeters off. Wow, it's exactly at 2 newtons. Okay, now for the next part of our experiment. Thank you, peanut butter. Oh, you saw that? Oh, jeez. Hi. Okay, so now we need to find how much work it took without the lever and how much work it took with the lever. Okay, so first we need to find out what our force was without the lever. Let me remember. That's right, our force was exactly 2.5 newtons. Now, we're going to times that by our distance, which was, it was 6 centimeters. But we always use meters, so it was 0.06. 0.06. Okay, now we are going to find our work. To find our work, we just multiply these two together. What does that equal? Let's see. Calculator. It equals 0.15 joules. 0.15. That's a lot of work. Woo! Okay. Next, we need to find it with the lever. First, we need to find our force. What was our force with the lever? That's right. You're so good. It was 2.0 newtons. 2.0 capital N. Next, we need to find our distance. What was our distance? That's right, it was 6 centimeters, but we always use meters, so it's 0.06. Okay, 0.06 m. Okay, now we need to find what the work was. To find the work, we just multiply these two together. What is that? It's 0.12 joules. Wow, you're so smart. Okay, so that means it took more work to do it without the lever. Okay, so we've had so much fun today, yeah. So we used our spring scale, our duct tape, our lever, and our ruler to find out that machines do make work easier. So, in conclusion, I conclude that my hypothesis was correct. Machines make work a whole lot easier. What a long day at work it was today. I should really get going. Oh, you're still here. I had so much fun with you today. I always enjoy doing the lever experiment. Well, I'll see you next time in the classroom. Bye-bye now. This video was created by Leela Wu, thanks to her assistant Madison LeCare and her very generous cameraman, Mommy Wu.